This video covers Unit 1.2. It's our second Unit 1, Lesson 5, from Wednesday, October 13th. So the first activity says, select all of the translations that take triangle T to triangle U, and there may be more than one correct answer. So you can see you have four options of how we are translating these points. You need to figure out which translations will take triangle T to triangle U. So please pause this video and complete the first activity. Now, you were able to select the correct answers and check your work, but the most important thing about this activity and the key takeaway is that we only need to describe the movement of one coordinate pair. So you'll notice like -3, 0 to 1, 2 to describe the translation of the whole shape. We don't need information about every single vertice or corner or point in order to understand the translation, because if one point is moving to a given coordinate, the whole shape follows, and we can find the rest of the points accordingly. So again, you only need one point to have the information you need about a translation. So the main focus of today's lesson is to translate using coordinates. So we're going to practice moving through the coordinate grid using those coordinate pairs. And it's going to give us the opportunity to see how coordinates can affect the translation, specifically, I should say transformation, because it'll be translation, reflection, and rotations of shapes. So in activity 2, you'll see it says 5 points are plotted on the coordinate plane. And using the pen tool or the text tool, your first step is to label each of the coordinates. So for example, if you just need a little refresher, A would be at about 0.5, 4. The first number is how far side to side, so it's about halfway to the x-axis. And the second number tells us how far on the y-axis, or how far up and down. So the first coordinate A would be 0.5, 4. You need to label all four coordinates. So go ahead and do step 1 and label all four coordinates. So step 2 says, using the x-axis as the line of reflection, plot the image of each point. And what that means is that you are reflecting the points across the x-axis or flipping them over. So when we have the point 0.5, 4, imagine if we folded the coordinate grid in half across the x-axis, you would end up with that same point right here, and the coordinates of that point would be 0.5, -4, because now we're below the x-axis. So the coordinates have changed to negative for that y value there. And we end up with the coordinate pair 0.5, -4. So go ahead and complete step 2 for points B, D, C, and E. You're reflecting them all over the x-axis. Okay, so at this point, you should have all 5 points labeled, and you should have a reflection of each point. I'm going to label my reflection A prime, which is the directions in D. So C says label each point with its coordinates. We already did that, and you should have already done that too in steps 1 and 2. And then 4 says label using a letter. So I said A prime because it's the reflection of A. So again, you should have 10 coordinate points all labeled, A, B, C, D, and E, and then the reflection over the x-axis. And you can always feel free to pause or rewind the video. Now, the next question says, if the point 13, 10 were reflected using the x-axis as the line of reflection, what would be the coordinates of the image? What about 13, -20, 13, 570, and explain how you know. Go ahead and pause this video and give this question a try. So from the previous example, you should have noticed that the points are changing based on the axis we reflect. So for example, when we reflected over the x-axis, when we flipped over x, the y value changed to its opposite. And that means that if we were reflecting, for example, 13, 10, the positive 10 would become a -10 because we're flipping over the x-axis. Don't forget to come back for part 2 of this video.